Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart with you as always. On the bench today we have a JCM800 4010, and this amp has come in because this model apparently is insanely bright. It has a huge amount of treble, which is actually very unpleasant, and the customer would like me to do a modification to reduce the treble. He's got a modification off the internet which I haven't done before, so I'm just going to have a look and see if that's suitable for this amp, or if we need to do a little bit more to tame the high frequency gain on this amp. So if you've got a JCM800 and it's screaming at you, this is probably the video to watch, and hopefully we'll be able to knock off a bit of that high frequency. So let's get straight into it and see if we can tame this amp. Okay, here we are inside the amp. I love these amps, they're very simple. Just uncomplicated, unfussy, compared to modern Marshalls with their layered and layered and layered stacked boards and their dozens of interboard connectors and just loads of stuff to go wrong. This is a fantastic, simple amp. Now, the little bit of circuitry we're interested in, let's have a look at the schematic. And here we are, here's the preamp schematic. Here are the inputs here. Little bit of amplification, goes off to another volume control, a bit more amplification, and here's the bit here that we're interested in. They put a very high value resistor here, 470k, and which of course will block a fair bit of the signal. In fact, look, there's a potential divider here with two 470k resistors, so the signal level here is half of the signal level there immediately. However, they bypass it with this cap here, 470 picofarads, so all the high frequencies go straight through there, so you get, you can imagine this is almost a short circuit to high frequencies, so that resistor is not even in circuit when the high frequencies are concerned, so you get double the voltage of high frequencies than you do low frequencies. This capacitor will block the low frequencies. So what we're going to do is change this for a 68k and remove this capacitor here. This is not a mod I've invented, it's a mod that's going around online and apparently quite a few people have done. So you could just snip this capacitor here and that would have the effect of killing some of the high frequencies. But they suggest changing this to 68k, so I'm going to do that and see what it's like. Now let's have a look at the actual board here. And here are the components here. We're looking for C8 and R10. So there we are, look, R10, just about see it there. C8, here's the cap here, and you might just be able to see that the traces are going from there to there. So this is in parallel with that resistor. So we're going to snip one leg of that cap. I'm just going to snip it off and bend it back in case anyone wants ever to restore that. And I'm not going to take this board out, I'm just going to put a 68k resistor in parallel with this 410 here, which will give just slightly less than 68k. So we'll do that. Now, I think before we do that, and just for our own interest, we'll put a signal through this and get it up on the scope, and let's check what the roll-off is at the high frequency end before we do any modifications, and then we can check it after we've done the mod and see what difference it's made. Okay, the amp is on and warmed up, and we're feeding a tone in from our signal generator at 1 kHz approximately, and we set the output to some arbitrary level. In this particular case it's 2, 4, 6, 8, 10 volts peak to peak, nothing special about that, just wanted something I could calibrate. And now we're going to gradually turn up the frequency here using this and see what happens to our waveform. See when it rolls off and goes down to a lower level. So I'm turning up the frequency now, and what you can see is actually getting larger, not smaller. So we're up at 2 kHz now, and the signal's bigger than at 1 kHz. This is a problem with this amp. This is what bright sounds like as we keep going up. Interesting funny little shape there. Tell you what I do want to do, I just want to check that the controls are central. No, we should have done this before. So we're just going to centralize these controls now. And let's just go back and set that all up again. So go back to 1 kilohertz. You know, if the treble control's turned up full, then of course we're going to get some issues. So let's make this so 1, 2. Let's make it a little bit bigger than that, I think. Okay, so we have 1, 2, 3, 4, 5 volts peak to peak at 1 kilohertz. Okay, let's do that again and turn up our frequency. Just going to keep increasing this. And as you can see, it is definitely increasing hugely in signal level. Look at that. That's a real boost. Going up and up and up. Look, it's a real treble boost. That massive treble boost there. I don't know whether it's all that capacitor and resistor that we're looking at, and it's bottoming out here a bit. I'm going to have to turn this down a little bit, I think. Just see what's going on here. Let's go up to 10 kilohertz and see how big this thing gets. See if it ever rolls off. Reset this again. It takes a bit of a while to get this kind of thing sorted out. I could have just cut to this and showed you you know, the final experiment, but I think it's useful just for you to see how these things go. Right, let's go back now to 1 kilohertz and see what we've got here. And we'll go, I think, for, let's set 2 volts peak to peak. Just going to turn down the input gain on the amp. That's about 2 volts peak to peak. I only want to get a rough feel for this. I'm not doing exact scientific measurements. 2 volts peak to peak at a kilohertz. Let's just go straight to 10 kilohertz. Oh my god. Look at that. That's 10 kilohertz. Insane. That's like 4 or 5 times the level. Mad. And as we wind up the frequencies, we're now at 20 kilohertz. Now it is starting to roll off a bit now, look. And that's 30 kilohertz. This is way out of the way out of human hearing. 30 kilohertz, 40 kilohertz. So yeah, this is amazing. So I think what I'll do now is just snip that bright cap and just see what difference that makes to the signal. So I'm literally just going to snip C10 there and see what that does. There we go, C10 snipped. Let's see what difference that makes to our signal. So we're going to go back to 1 kilohertz and get this set up again. And we are at slightly over two divisions there. Right, let's wind up the frequency again. In fact, let's just go straight to 10 kilohertz. Look on the signal generator, 10 kilohertz, bang. What a difference. Oh, wow, that bright cap is really pouring signal through. That bright cap on the the 470k resistor. So yeah, the customer's absolutely right on this. Crazy high frequency. Now the thing is, do we like that roll off at because that's 10 kilohertz, which is that's 1k. So what's the 3 dB, 6 dB? That's 2k. Oh, there's a bit of a boost there. Look, so we're getting a little bit of boost, not much. 3k, 4k, so a bit of middle boost there, which might sound quite nice. Now we're up to 6k. This is quite a high frequency, 6,000 cycles. Now we're back to normal. Look, back to the two divisions, and that's 7k. And we're 6 dB down at that 10k roughly. Yeah, just over 10k. So we're 6 dB down at 10k. I think 10k is a very, very high frequency. Are we happy with that? Or I tell you what we should do. We should try the 68k resistor now. and see what that does, and then just see what this mod is like, really. I don't know the provenance of this mod. I'm just slavishly following it, to be honest with you. But let's change that 470k for 68k, and then see what the frequency is doing. I think I'd prefer if it wasn't rolling off at 10k, if it was rolling off more like 15k or something. But anyway, let's have a go. Okay, well, one of the problems with filming and repairing is you tend to make mistakes, and I've just made a stupid one, and yet I've clipped the wrong capacitor. I've just put that back for the moment. I might tidy that up, I might not, we'll see. And the capacitor we want is this one, C8. So we'll clip that and then have another look at what the frequency response is. Right, there we go, correct capacitor clipped. And let's have a look to see what's happening to the frequency response now. Okay, 1 kilohertz on the signal generator, 2 divisions on the scope. Let's go straight up to 10k and see what happens. And we have a little bit of a boost, look, interestingly enough. Yeah, we've got a still got a boost there. Nothing like what we had, but it's still fairly large. So let's keep going up in frequency. Oh, that's rolling off now, look, see. So that's rolling off at, well, funnily enough, I wanted 15k, didn't I? That's rolling off at about 12.5k. So that's not too bad, but still we do have this boost. Look, we've got 2 divisions, just over 2 divisions. Let's just bring that down to 2 exactly. So 2 divisions there at 1 kilohertz. Get this right. 2 divisions at 1 kilohertz, and at 10 kilohertz we have 1, 2, 3, 4 divisions. So we've got a 6 dB boost at 10 kilohertz still. That's still quite bright. So let's now do what I was going to do, which is put that 68k resistor in and see what that does to the frequency response. Okay, there you go. That's how I've put that 68k resistor in parallel with a 470k. So that resistor will now be 65k or something, or 66. I can't be bothered to do the calculation, but it's very close to 68k. Right, so let's now see what that has done to the frequency response. And here we are, 1 kilohertz, 2 divisions. Let's go straight up to 10 kilohertz, see what happens. And we still have that. In fact, if anything, it's increased that. That's very interesting. Well, that's interesting. It's increased the boost there. So I'm not really keen on that. I don't think that's the way to go. Fascinating. And I'm going up now. 15 kilohertz, 12, sorry, kilohertz, 13, 14, and again it comes down at about 15 kilohertz. It's back to what it was at 15 kilohertz. So that's interesting. So 1 kilohertz is, oh, it's got quite a, that's interesting. It's got quite a bass roll off this amp. Let's just see what's doing down to low frequencies. So that's 1 kilohertz, and then 100 hertz. Yeah, that's just, well, 100 is quite low. Let's go up to a couple of hundred or something. Yeah, a bit of a bass roll off here. A bit of a mess, the frequency response of this amp. I don't really like it to being 6 dB down at 200 hertz there. That's 500 hertz, and it's 3 dB down. That's 1 kilohertz, and it's what we would call nominal, our 2 divisions. And as we go up in frequency to 10, it zooms up in frequency. Massive. Okay, now take that 68k out again. Right, well, I've been messing around for about half an hour with various capacitor values without a huge amount of luck. Now what I've done now is I've snipped this one here. This is another very bright cap here. Again, 470 picofarad across there. Massive, massive, massive treble boost on this amp. I don't know what they were thinking of. But anyway, so what we've got to is that, where are we? So let's say at 500 hertz, we are set 2 divisions at 500 hertz. So we're there. As we go up to 1000, so at 1 kilohertz now, a little bit of a boost there, look. Now we'll go back to scale right, just winding it down again so I can change the range. Right, there we go, and now we're still at a kilohertz there, so look, a little bit of a boost there at 1 kilohertz. And then as we go up, we're getting, you know, a bit of a boost there, so 6 dB at 2 kilohertz. Let's just see what that mid control does. I'm just going to turn the mid. This is the world's worst tone control. That's maximum to minimum, that. It's absolutely useless, that tone control. God, dear me. Let's go up to 3 kilohertz. Staying pretty flat. So we've got a, you know, 6 dB boost up in the mid range there. I'll just try this middle again. Not doing anything. That's full range. You won't even hear that. You won't hear that at all. 4 kilohertz, staying pretty flat now. Look, now it's rolling back down off a bit now. So, but now at 10 kilohertz. Now bear in mind that that is the same peak to peak as we were at 500 hertz. So we've got a bit of a sort of mid boost on this amp. Now let's go back down to range again, so I can turn up above 10 kilohertz. Right, 10 kilohertz, so we're now, that's 10 kilohertz. Now we're going up, look, in frequency, and we're 15 kilohertz, that is, so no point going much above that, and it's 6 dB down at 15 kilohertz, which I think we might leave it at that, actually. Certainly a big difference compared to what it was with that massive, huge boost at the high frequencies. Now we can reverse all this if we need to, so I'm going to send it back to the customer and see what he thinks, see if he likes the sound of it. At the end of the day, it's down to what the customer wants and whether he likes it or not. Some people might like a screaming high frequency amp. So we've chopped this one here. This is allowing all the high frequencies to bypass this huge resistor here, giving a massive treble boost. We've chopped this one here, ditto, all the high frequencies bypassing this resistor, giving a big treble boost. And this tone control is arguably the worst tone control in the world. It has very, very little effect. Bass doesn't do anything, middle doesn't do anything. I guess we haven't tested the treble. Let's put our hands on the treble there. And where are we in frequency? Need to go up a bit. Yeah, we're at, we'll come down to something a bit more sensible. Let's go. Let's get a 5 kilohertz or something. 5 kilohertz is very high frequency. Right, 5 kilohertz, there we go. So let's just see what the treble control does. Where are we? Here. Yep, treble control is fairly effective, look. That works nicely. So that's good, because if we don't like those, we don't like that 6 dB boost at whatever kilohertz, we can back that off with the treble control. That's good. But middle, let's go down to 2 kilohertz. Well, maybe, I don't know. Quite sure what middle is in terms of frequencies. Yeah, kilohertz or something, won't it? Middle control. That's the presence control. It gives a little bit of a boost there, and the middle has almost no effect. That's full range I'm doing there. You can hardly even see the change. Look, one side of the pot, the other side of the pot. See nothing. Let's come down a bit in frequency to, I don't know what, 1 kilohertz. just below 1 kilohertz. Middle. Oh, okay, so a little bit. Alright, so they're saying that middle is around about, is a lower frequency than I thought it might be. That's yeah, oh well, nothing to write home about. Right, I think I'm going to leave it at that now. That gives the customer a little bit of control over the sound. And we can move on to a couple of other things I want to do on this amp, which is just really to test the bias and to make sure it's delivering full power. I won't bore you too much with that. There's the bias control if you should need to bias this amp. But the video's been a bit longer than I thought in terms of getting this this tone sorted out, and so I think I'll leave it at that and just keep this as a video on adjusting the tone of the JCM800. I'm sure you'll probably be screaming at me to say you know, change that capacitor or alter that capacitor. I did have a mess around with this one, and that didn't really do anything at all. I increased the value of that. It gave a couple of dB boost on the bass, but nothing. There's nothing else here which we can do to actually boost the bass. We can reduce the treble, which has the same sort of effect. But in terms of actually giving it a bass oomph, there isn't really anything here that we can do. I tried changing that one, no effect whatsoever, literally no effect. Not quite sure why. Yeah, maybe you're shouting at me. I should have done something, but I'm afraid I can't work out what it is at the moment, so that's the best I can do. Okay, well, I thought you might like to hear the amp. Sorry I didn't do a before video, which obviously would have made sense, but I didn't. Ooh, that's quite nice actually. That has a bit of an effect. So does that. Yeah, so does that. Yep, I can hear the effect of all those controls. That's quite nice now. That has actually sounded quite good. I bet it was screaming before. So I like the sound of that. That's alright, I'm quite happy with that. Okay, well there you go. I won't do a formal exit. Thanks for watching that. I hope you enjoyed it and got a little bit of knowledge from it. It was a bit of a learning exercise for me, as you probably noticed. And I think the customer will be fairly happy with that. I'll catch you on the next video, and thanks as always for watching.